All right. Live from the hurricane, this is our review for our second test in geometry on similar triangles. And so I'm going to try to go through as many of these questions as I can without losing power, hopefully. So number one says, in a diagram below of triangle ADE, B is a point on AE, and C is a point on AD, such that BC is parallel to ED. So you have this line segment parallel to that line segment. AC is x minus 3. Okay. BE is 20. AB is 16. And AD, so A to D, is 2x plus 2. They want us to find the length of AC. So if we find x, say for example x was 10, AC is 10 minus 3, which is 7. Important, we have two triangles here that are similar. We have this guy up here and the big triangle. And what's really critical is we have to make sure that we build our sides. So if you notice, they actually built one for us. The 2x minus 2 is actually already built for us, which is great. So we just have to build side AE, which is 36. Just add the two sides together. And now we can set up a proportion. So here's our proportion. It's 16. Well, here's one you can set up. 16 over 36 equals x minus 3 over 2x plus 2. And then we'll cross multiply here. So 16 times 2x is 32x, plus 16 times 2 is 32, equals 36x, minus 36 times 3 is 108. And now you have a simple linear equation, so I'll subtract 32x from both sides. So 32 is equal to 4x minus 108. Add 108 to both sides, and we get, let's see, 140 equals 4x. Divide by 4, and x turns out to be 35. X is 35, but they asked us to find AC. Okay? Notice we have to answer the question. They asked us to find AC. AC is here. You really can't see my highlight, but that's okay. AC is x minus 3. Now that we know what x is, it's 35 minus 3, which is 32. Final answer. All right, number 2. In the diagram below of right triangle ABC, altitude BD is drawn to the hypotenuse. AC is 16, CD is 7, and they want the length of BD, so I'm going to put an X on here. Now, if you notice, we want to find AD, so we want, BD. We want to try to get BD involved. BD is in this blue triangle, and it's also in this, whoops, was supposed to be yellow. It's also in this yellow triangle, so it kind of gets shared in the green there. These two triangles are similar, and here's why. Okay, we have, well, actually, they're similar to the big triangle. So notice the big triangle has a right angle. These two little guys have a right angle. Okay, we're not going to use the big triangle because x is not involved in that triangle. So what we're going to do is actually use the two triangles that I highlighted and come up with a proportion. Well, if I look at the yellow triangle, let's say I look at the blue triangle for a minute. X looks like my larger leg and 7 looks like the smaller leg. So I'm going to start off with that as my fraction. X over 7. So large leg over small leg. That's how I'm building the proportion. Equals, my large leg in AD looks like it, in triangle ADB, looks like it's AD. AD is 16 minus 7, which is 9. So here's my large leg in the other triangle, divided by my small leg, which is x. And notice this works nicely because I get two of the same thing on the diagonal. That's a key that you did this right. So cross multiplying, we get x squared equals 9 times 7, which is 63. Take the square root on both sides, and I get x is square root of 63, which needs to be broken down. So this is how I do it. I'll show you two ways, actually. One way is to write down your perfect squares on the side of the paper. Okay, you should know these. And I'll stop at 64. 63 is right here. And so I go up the list and divide each of these numbers, 63 divided by each of these numbers, and I look for the largest one that divides into 63. So it happens to be 9. So this is x is equal to the square root of 9 times the square root of 7, which is 3 square root of 7. And that's the final answer. Another way to break down a radical is to factor it any which way you can. Whoops, sorry. So for example, we can factor 63 into 9 times, let me erase this, I don't like the way I'm doing this. We can factor 63 into, say, 9 and 7, then factor 9 into 3 and 3. Circle pairs. A pair comes out and is represented by 1, 3, and then the 7, since it's not paired, has to stay in. Either way works. Number 3, two triangles are similar and the ratio of each pair of corresponding sides is 2 to 1. Which statement regarding the triangles is not true? The areas do have a ratio of 4 to 1. So if my sides ratio was 2 to 1, to get the area ratio, I square, and we saw this in the lesson that we did on this, we can square the area ratio, square the sides ratio to get the area ratio. So this would be the area ratio, and that's actually true. That's true, not the answer. Their altitudes have a ratio of 2 to 1. We saw that altitudes kind of make similar triangles. That's one way to look at it. Also, altitudes are heights. They're line segments, so they have the same ratio as the corresponding sides. Perimeters also have the same ratio as the corresponding sides. The angles, however, always have a ratio of 1 to 1. Okay? Choice D is the answer. That's not true. All right, number 4, we want the length of AB. We have two similar triangles, ABC and DEF, and we want to get the length of AB, so we'll set up a proportion and solve it. So we have 7x over 7. This is one way to do the proportion. I'm doing left large over left small equals bottom large over bottom small. So 4 over x. Cross multiply here, you get 7x squared equals 28. And I want to get the x squared by itself first, so we can divide by 7. X squared is equal to 4. And now we can take the square root on both sides. In Algebra 2, I want you to put plus or minus here. We discussed why. But in this class, we're good enough with just x equals 2, since 2 is representing a length. We want the length of AB as prescribed by the question. AB is here. Whoops. AB is here. So we'll plug in 7. We'll plug in x equals 2 into 7x. So AB is equal to 7. Whoops. AB is equal to 7. Why is this not writing? Sorry, so AB is 7 times 2, which makes AB equal to 14. Choice C. Number 5, we have two similar triangles. DE is 4, AB is x, AC is x plus 2, and DF is x plus 6. We're going to determine the length of AB. Firstly, we must set up a proportion. So I'm going to do x plus 2 over x plus 6 equals x over 4. And we're going to cross multiply this, so we have to be careful. I have to multiply 4 times all of x plus 2, which will give me 4x plus 8. Then I must multiply x times all of x plus 6, which is x squared plus 6x. This is a quadratic as made by the guest appearance of J Beebs, or x squared. We're going to move everything over to that side. So I'm going to subtract the 4x. And I'm going to subtract 8. And so we'll get 0 equals x squared plus 2x minus 8. Factor this thing. We get x plus 4 times x minus 2, which means that x is equal to either negative 4 or x is positive 2. However, x cannot be negative 4 because x represents a length. So we're going to reject this. And we're going to keep x equals 2. And then we're going to make sure we're going to answer the question. So if x is 2, I want the length of AB. So AB, notice the question wants the length of AB. AB happens to be right here. And AB is just x. So guess what? This is actually, the question here is very simple. AB is just equal to 2 since it was x. All right. Number 6, another similar triangles question. AC is parallel to DE. CE was 25 inches. AD is 18 inches. And DB is 12 inches. And we want to find EB. So notice I'm going to highlight the actual triangles. Here's one actual triangle. And here is the other actual triangle. Okay? And so we're going to use proportions based on those. So notice, and before I do my proportion, I have to build sides here because C to B is a side, not C to E. That's the trap. I'm going to add these two guys. I'm going to call this x plus 25. And I'm going to add these two guys and call this 30. And now we can set up a proportion. So I'll start here. My small over my big corresponding equals my small over my big corresponding. So now we get 30x equals, I must distribute the 12 to all of the x plus 25, which gives us 12x plus 300. I'll subtract 12x on both sides, and I'll get 18x equals 300. Divide by 18. And x, I believe, is 16.6 with repeating. We want to find this to the nearest tenth. EB is x, so that's good enough. I can say EB to the nearest tenth is 16.7. If you're not sure on the rounding on this, 16.6 repeating looks like this. I want to round to the nearest hundredth. This guy says, rounding to the nearest tenth. The 6 in the hundredths place says to the 6 in the tenths place, move up 1. All right, number 7, triangle ABC is similar to ZXY. So here's my ABC. You gotta forgive my handwriting on this. And here's my ZXY. I'll make ZXY a little bigger. And so A was 50, C was 30, and they're asking us for angle X. But notice, since the triangles are similar, corresponding angles are equal. So angle B and X are equal. So in order to find angle X, I'll just find angle B and we'll be done. So we'll add up the two angles we know in the triangle, and then we'll subtract from the known sum of all angles of a triangle. We'll get 100 for angle B. Therefore, we'll have 100 for angle X, and we're done. Number 8, we have two triangles, and we know the ratio of AB to DE is 3 to 2. Which statement is not true? So this is the sides ratio. The sides are in the ratio of 3 to 2. BC and EF also correspond, and they're in a ratio of 3 to 2, so that's true. So that's not the answer. A and D are also corresponding, but they're angles. So the angle ratio is 1 to 1. Okay, we just saw that in the last problem. So for example, if I took the ratio of, say, this angle to this one, angle C is 50 because in similar triangles, the angles are actually equal. And if I took the ratio of 50 divided by 50, that's 1 to 1. So the same thing happens here. So that's actually the answer. That's not true. This is false. Whoops. The area ratio is 9 to 4 because to go from the sides ratio to the areas ratio, you just square the sides ratio and you get 9 to 4, which is the area ratio. So that's actually true. And the perimeter ratio is identical to the sides ratio. So only choice B is false. Number 9, a very similar question. We have the ratio of the lengths is 3 to 1, which ratio must also be 3 to 1. A and D are corresponding to each other, so the angles are in a 1 to 1 ratio. B and F aren't even corresponding, so we don't know what this relationship would be. It could be 3 to 1, but we don't know what it is. If it was angle C, for example, to angle F, then this ratio would be 1 to 1. But since B is the middle letter here and is the last letter here, they don't correspond. The area ratio is this ratio but squared. So this would be 9 to 1, not the answer. And the perimeter ratio is always identical to the sides ratio. So there's your answer. Number 10, we have a diagram. We have a big right triangle and an altitude drawn, so we get our similar triangles. AB was 36 and AC was 12. We want the length of AD. So here's little AD. Now, what triangles can we use potentially? Well, I have this big right triangle, which I already know 2 sides in, which is great. I'm going to start off with that. So I want to make a little fraction out of the 2 sides, 36 and 12. Okay? So 36 over 12, and I want to ask myself, well, what's the role of the 36? And the answer is, in the big right triangle, it is opposite the right angle. So the role of it is it's the hypotenuse. Over 12, 12 is a leg, it's the short leg. I'm just going to write short L for leg. Equals, now I'm going to use the other triangle that I know something in, which is this guy here. This triangle right here. And I didn't really do a good job highlighting it. Hold on, maybe I can erase this and highlight again. So here's my big triangle. Okay? And here, actually, let me do a smaller highlight. This is the little triangle. And now I want to do the same fraction again, except I'm going to use the hypotenuse of the green triangle, which is 12, over its short leg, which is x. And now we're in business. So we have 36x, cross multiplying here, equals 144. Divide by 36. And if you do this division, you get, I believe, 4. And AD is what they wanted, so that's the answer. Very straightforward. All right, number 11, we have another similar triangles question. We have the parallel lines, which you know if you draw a line parallel to another side in a triangle, you make 2 similar triangles. So AT is 5, TB is 7, and AV is 10. And they want us to find VC. So again, rule of thumb here is you really want to build your triangle. So here is my little triangle. And here is my big triangle. And I want to build the sides up. So the yellow triangle is done, but the green is not. I want to build up my side here. X plus 10. Build up my side here and get 12. And now we can set up a good proportion. So I'm going to do, you can do this several ways. I'll do 5 over 12. I'll start there. So little over big all on the left equals 10 over x plus 10. Cross multiplying here, I must remember to distribute my 5 to the x plus 10, which is 5x plus 50, equals 120. Subtract 50 on both sides. We get 5x equals 70. Divided by 5, x equals 14. And we wanted VC, so we're done. X was VC, we just got it, 14. Number 12 is a little trickier. It says in the diagram below, RST is a 3, 4, 5 right triangle. So they're talking about this guy. Whoops, that was bad. That's what happens when you don't have a smart board. You're working on a tablet here. So 3, 4, 5, this guy is a 3, 4, 5 right triangle. And the altitude's drawn. We want to determine the length of the altitude. So here's the issue, right? I have this big right triangle, and then I have 2 similar triangles. So if you notice, I'm going to pick this triangle. It actually doesn't matter. I have this guy here, okay? So if you notice something, let's say I want to use the green triangle somehow, okay? I have everything about the green triangle. I have the 2 legs and the hypotenuse. In the blue triangle, I have its hypotenuse, okay? Notice this is the hypotenuse of the blue triangle, okay? So here's the thing. I'm going to start off with the green triangle and say, okay, I have my hypotenuse, and I have a leg. And I'm going to choose 4. You could have done the 3, but I'm going to work with the blue triangle, so I'm going to use the 4. And this is from the green. Okay? This was the hypotenuse, and this 4 was the long leg. I'll abbreviate it like that. Hypotenuse over long leg equals. Now I'm going to look at I'm going to do this, I should color code this. I'm going to look at the blue triangle now, and I'm going to get its hypotenuse and long leg. So the hypotenuse is 4. The problem is the long leg is not h. They wanted us to find h, but the long leg is not h. If you notice, a is longer than h. So a is the actual long leg here. Okay? But here's the thing, right? If we get a, we can get h a number of ways. So we'll talk about how to get that, but understand that this is the short leg. Okay? And this leg is a little bit longer. Another way to see this is that the two triangles share this angle right here. Okay? So your hypotenuse is 5, and then you're doing long leg, which is 4. But in the green triangle, the 4 is opposite this angle over here. It's not opposite this angle. So h has no role in this proportion once you choose the 4. It's the a, it's the long leg that has the role. Anyway, so we get 5a equals 16. Divide by 5. And a turns out to be 3.2. So a is 3.2. That's great. I want to clean this up a little bit. Now that we know a is 3.2, clean this up a little bit. A is 3.2. Okay? We can get h in 2 ways. One way we can get h is to use the Pythagorean theorem. We can use the Pythagorean theorem on this triangle. So I'll do that. That's one way to do it. I'll show you another way to do it in a minute. So here I'm going to use the Pythagorean theorem. I'll do it in red on that triangle. So I'm going to go h squared plus 3.2 squared is equal to 4 squared. So we get h squared, whoops, we get h squared plus something that I have to figure out. We get 10.24. Hey. Pen. Oh, I'm pressing that. Okay. Sorry, I'm just getting used to this pen. Okay, great. 10.24 is equal to 16. We'll subtract 10.24 from both sides. And you get h squared is 5.76. Take the square root on both sides. And this is a perfect square. You just type this into your calculator. H turns out to be 2.4. Another way of doing this, so here's way 1. Call this way 1. All right, and you got to do the initial piece that we did. So this initial piece must get done. Whoops. Way 2 is to think of using b in a proportion. Well, how do you get b? b is 5 minus 3.2, which is 1.8. And now you can use this triangle in conjunction with the other one. So we can think of starting off a proportion, doing long leg over short leg. So that's what I'm going to do. I'm going to do long leg over short leg in the blue triangle. So long leg is 3.2, and short leg is h rather. Equals in the yellow triangle, h is the long leg. I hope you see that. H over short leg, which is 1.8. 3.2 times 1.8 is 5.76, which equals h squared. Taking square roots, h is still 2.4. Which makes sense because h is the small leg in the blue triangle and the large leg in the yellow triangle. The video get too large because I'm doing it on my laptop. This will be the second review video. I'll start at question 13 and see if I can get all the way through. In the diagram below, we have the lengths of legs AC and BC of a right triangle of 6 and 8. And they want the length of this. Now, what's interesting here is I'd like to set up a proportion. I have 2 full sides in my yellow triangle. I have 1 full side in this green triangle. However, the problem right now is that the 6 is the hypotenuse of that green triangle, and x is the short leg. Okay? But of the yellow triangle, I don't have the hypotenuse yet. The hypotenuse would be AB. So I can't go start setting up something like 8 over 6 equals 6 over x, because 8 is not the hypotenuse of that triangle. So we have to first get the hypotenuse of the triangle. So we have to get the hypotenuse of triangle ABC. And then secondly, we can set up a proper proportion. So here's the first thing we're going to do. We're going to get the hypotenuse of triangle ABC. And to do that, we'll just use the Pythagorean theorem. So here's my step 1. 6 squared plus 8 squared equals, I'll just call it hypotenuse squared, or just c squared. 6 squared is 36, 8 squared is 64, that equals c squared. 100 equals c squared, and so c is 10. So here's my hypotenuse now. And this is the hypotenuse of the large triangle. Now we could set up a proportion. And again, the whole motivation for doing this is that 6 is the hypotenuse of the green triangle. So in order to set up a proportion using the big yellow triangle and the smaller green triangle, I needed to get the yellow triangle's hypotenuse. So we'll do that now. We'll set this up. So I have my hypotenuse of the big yellow triangle, which is 10, over the leg, the short leg, which is 6, equals, now I can deal with the green triangle. The hypotenuse of the green triangle is the 6 over its short leg, which is x. So we're going to cross multiply here. We get 10x equals 36, and divide by 10, and x is 3.6. Choice A. This is a harder question, but I really like this question because if you understand all the concepts, then this is the question for you. And I'm pretty likely to put something along the lines of this on the test. All right, number 14, we have 2 similar triangles. And notice ABC and EFG, C and G correspond. And so they told us C was 4x plus 30, G was 5x plus 10, and those are equal. They're corresponding angles. So I probably should write it. I probably should draw it like this. So here's one angle. Here's the other angle. And now we just have to set them equal to each other and find x. So we'll do that. So I have 4x, 4x plus 30 equals 5x plus 10. Subtract 4x on both sides, and I get 30 equals x plus 10. Subtract 10, and x is equal to 20. And that's it. Number 15, diagram below of right triangle ABC. CD is the altitude to the hypotenuse. CB is 6, AD is 5. Again, we have a big right triangle and 2 smaller right triangles, so we can set up our proportions. They're asking for the length of BD, so on that I will put x. On BD I will put an x. And we want the length of BD. Now here's the thing with this one. You have to look at what triangles you have stuff in. Well, one might be tempted by the left triangle CAD, but notice x is not in that triangle. and 6 is not in that triangle. So we just have the 5 in that triangle, and that's a tough one. So I'm going to avoid using that triangle. Here's one triangle to use for sure, because it has both the 6 and the x in it. So right now I'm going to use that triangle and set up a proportion. 6 over x, let's say. The 6 is the hypotenuse of that triangle, and x is the short leg. So I now need to go and get the hypotenuse, or be able to express the hypotenuse of some other triangle in some meaningful way here. But here's the thing. If I choose this side triangle, I don't have any information about the hypotenuse. We know nothing, we know nothing about the hypotenuse of this triangle. So this triangle I'm not going to use. So I'm stuck with using the bigger one. And you might say, well, I don't know the hypotenuse of the bigger one. But, sorry, let me undo that. But what we do know, at any rate, is that of the big triangle, I can at least express the hypotenuse in terms of x. So this is x plus 5. This is the hypotenuse of the large triangle. And note, at least it has an x in it. See, that's the thing. AC is the hypotenuse of the left triangle. But the problem is, I don't even know what that is in terms of x. The right triangle, at least I can build the hypotenuse in terms of x. So I have hypotenuse over short leg. The short leg of the yellow triangle is the 6. And notice, I have my 6 and 6 on a diagonal. So I have 6 times 6 is 36, equals, remember to distribute here, I'm distributing the x to the x plus 5 when we cross multiply. We get x squared plus 5x. This is a quadratic. I'll move everything over to where the x squared term is. So I get 0. That looks like a chunky 0. So I have 0 equals x squared plus 5x minus 36. I'll factor this. I get x plus 9 and x minus 4. And so I get x is negative 9 and x is 4. Since x represents the length of BD, I must reject negative 9 and keep 4. And there's my answer. That's a harder question, too. Another really, really good, smart question. And these are all Regents questions. All right, number 16, the diagram below of right triangle ACB. We have the altitude coming down from the right triangle, so we can use proportions in this picture. AD is 3, DB is 4. They would like us to find CD in simplest radical form. So we will do that. And this is a pretty straightforward one. X is shared by this triangle, and x is also shared by this triangle. So I'll pick the yellow one. I'll start off with the yellow one. Here's my yellow one. I'm going to do long leg over short leg, which is x over, which is x over 3, equals, I'll do long leg over short leg, equals 4 over x. And again, the x plays the dual role. It plays the short leg in the blue triangle and the long leg in the the yellow triangle. And now we can cross multiply. We get x squared equals 12. Taking square roots, x is square root of 12. Looking at the biggest perfect square that divides into 12 is 4. So this is the square root of 4 times the square root of 3, which is 2 square root of 3. Final answer. Number 17, another familiar picture. We have the parallel lines inside the triangle, which makes two similar triangles. Here's one. Whoops. That's pretty bad. I'm going to undo that and try again. Here's one. And here's the other. Okay? And we have, let's see, a bunch of stuff here. So CB is 3, CA is 10, so C to A is 10. Be careful, they're actually giving us that. That's nice. And CE is 6. They want the length of ET. So there's two ways you can do this. I want to put an X on ET. And remember that I have to build my side. X is not a side of a triangle. I don't want to use it. So we can set up a proportion with our side. So we have 3 over 10. Hey, whoops. 3 over 10 equals 6 over x plus 6. Cross multiplying, remember to distribute. 3x plus 18 equals 60. Subtract 18. We get 3x equals 42. Divide by 3. And x is 14. ET is x, so that is our answer. Number 18 in the diagram below of triangle ACD, E is a point on AD and B is a point on AC such that EB is now parallel to DC. And again, we've seen this picture I don't know how many times. It's going to produce two similar triangles for us. Here's one, and here's the other. Okay? And so we have AE is 3, ED is 6, and DC is 15, and they want us to find EB, so I'm going to put X on there. And again, we have to build the side. 6 is not a side of a triangle. So we're going to build this and make it a 9. So now we'll set up our proportion. I'll do 3 over 9 equals X over 15. Cross multiply, you get 45 equals 9X. Divide by 9. X is equal to 5. Number 19, it says in triangle ABC. So here's my, that's a pretty rough triangle. I'm going to try again. Again, I'm sorry, I'm doing this on a tablet, not on a smartboard. Takes a little getting used to. So here's my triangle, let's say. That's better, sort of. D is, so ABC, right? D is a point on AB, and E is a point on BC, such that DE and AC are parallel. I'm going to do that up here. So here's my E. Here's my D, and these guys are parallel. So DB is 2, DA is 7, and DE is 3, and we want to find AC. And I mislabeled something. This is BE. They told us DE was 3. That's better, and I can put an X here. And again, we have our similar triangles. One's here, okay, and one is here. And we have to build our side. Again, such a critical concept. 2 plus 7 is 9. And now we can set up a proportion. 2 over 9, this is one way to set it up, equals 3 over x. Cross multiplying, we get 2x equals 27. And divide by 2, x is 13.5, which is the answer, because they wanted AC, and we're done. Number 20, it says in the diagram, angle BMN, this guy, is congruent to angle A. And notice, this is going to produce similar triangles for us because we have this triangle up here, and this triangle down here. Okay? And the triangles happen to share this angle up here. So we get similar triangles. So AM is 3. AC was 15. MB was 6. And we want to find MN. So again, we have to build the side. 3 is on the side of a triangle, but 6 plus 3 equals 9 is. And now we can set up our proportion, which will be 6 over 9 equals x over 15. 15 times 6 is 90 equals 9x. Divided by 9, x is 10. And we're done. 21, right triangle ABC, we have altitude AD drawn. So we have right angles up here and here. BC was 10. DC was 8. And we would like to find AD, so I want to put an X on AD. Now notice, AD is a member of the two smaller triangles. So AD here is a member of this triangle, and it's also a member of this triangle. Oof, that's bad. Hold on. It's also a member of this triangle. Notice I can really draw straight lines in this little program. So, here's the issue, though. In the yellow triangle, we don't know anything, unless we're a little clever here and say, oh, wait, I have 10, and then I have 8 for DC, so that makes this, if I subtract, 2. And now we can set up a proportion. So, for example, I'm going to use the green triangle, and I'll say long leg over short leg, which is 8. Let's just erase this. Hey. 8. Ah, that was bad. Hold on a second. Just still getting used to this. Nope. Don't want to do that. Just would like to do this. Okay. So we have 8 long leg over short leg in the green triangle equals long leg over short leg, which is x over 2. And again, another way you can check this is on the diagonal you have the same thing. Cross multiplying, I get x squared equals 16. Take the square root, and x is 4. All right, 22 says determine the value of the variable, simplify your answers. So, yeah, again, you have to decide what triangles you're going to use. I'm clearly going to use this left-hand triangle because it has a number and it has my x in it. So if I start making a fraction with that, the x is the hypotenuse and the 6 looks to me to be the short leg. Okay, so I'm going to start off with x over 6 equals, now here's the thing, I have to come up with another triangle that has something in it. So, that we've already used, kind of. So here's my other triangle, the other little guy. And if you notice, I have an 8, but there's no way I can get anything else from that triangle. So I'm not going to use the green triangle. But, luckily, we have one more triangle, which is the big blue one that I'm highlighting now. And we're going to use that big blue one because, at the very least, I can get its hypotenuse in small leg. The hypotenuse, are these two pieces added together, which is 14. So 14 over its small leg, we did hypotenuse over small leg equals hypotenuse over small leg. Its small leg is just x. And again, we have the same thing on the diagonal. So we have x times x is x squared. 6 times 14 is 84. Take the square root. X is the square root of 84. I'm actually going to simplify this using my factor tree, just for a change of pace. 81 is 2 times 42. 42 is 2 times 21. And 21 factors into 3 and 7. But 3 and 7 won't produce any pairs. The only pairs I'm going to get are 2 2's, which come out of the radical as a 2, and 21 stays in the radical. And remember, they asked me to simplify the radical answers or express your answer in simplest radical form. This is what we want. If you wanted the perfect squares chart, you would realize that 4 is the largest perfect square that divides in 84, and the square root of 4 is 2. Either way, I don't care which way you get your answers. The factoring method, I think, sometimes is a little harder, but next year you're going to want to use that method because you're going to do cube roots and fourth roots and all that stuff. All right, 23. We're going to find x and y this time. I'm going to find x first, though. Notice they gave us the altitude in this triangle, which is 6. So here's one triangle where the altitude exists in, and here's another triangle. Okay, notice the green is where they share. So in this case, we have legs. Say I took the yellow triangle for a moment. We have the legs. I have the long leg and the short leg. So here's my long leg and my short leg. And that equals, in the blue triangle, the long leg is the 6 now, and the short leg is the x. Again, on the diagonal, I have 2 of the same thing. So important. So now we're going to cross multiply. We get 36 equals, remembering to distribute the x through, I have x squared plus 5x. I'll subtract 36 on both sides. I get 0 equals x squared plus 5x minus 36. So now we can factor this. So we can factor this into, 0 equals, we get x plus 9 times x minus 4. So x equals negative 9, which we must reject because it's a side length. And x equals 4. So x is equal to 4, which is great. And we can now use that fact here. X is 4. So I do want to find y. So there's actually a couple of ways you can find y. Once you know x is 4, you could use the Pythagorean theorem and find it. So we'll do that. So I want to find y. I'll do this in red, say. I can do 4 squared plus 6 squared equals y squared. I can use the blue triangle and use the fact that y is its hypotenuse and 4 and 6 are its legs. So 4 squared is 16 plus 6 squared is 36 equals y squared, making y squared equal to 52. Taking the square root of 52 is y squared. We need to simplify this. So I guess I'll simplify this using the prime factoring method. 52, if I split this up, I can do 2 times 26. And then 26 can be 2 times 13, and that's it. I have a pair of 2's. So 2 can come out, 13 stays in, so that's y. Or another way to simplify square root of 52 is find the largest perfect square that divides into 52, which is 4. And 13 is left over. And that way we get 2 radical 13. Okay? Now there's another way you can go about finding y. You could use, and I'm actually going to erase this. I'm going to erase this stuff because we know what x is. Just give me a moment here. I'm going to erase all this. We know what x is. So how can we find y a different way? Well, first of all, if you found y using Pythagorean theorem, you don't have to. But this is another valid way of doing it. I can look at, and I'm going to do some erasures here. I can look at the big triangle, okay, this big triangle, and realize that if I have x, that I can get its hypotenuse. I needed the hypotenuse because y is the hypotenuse of the green triangle. So I can get the hypotenuse, knowing x is 4. That makes this whole thing 9, right? Plus 4, which is 13. And so now we can do this. We can go hypotenuse 13 over short leg y equals y hypotenuse over short leg, which is 4. 13 times 4 is 52 equals y squared, which is the same exact equation that we got there. And so we're going to get the same exact answer. So y is 2 radical 13. So final answers, x was 4, y was 2 radical 13. Okay? 24, in a right triangle ABC, altitude BD is drawn to hypotenuse AC. If BD was 12 and DC is 8, I would like to find AD, which I'll call x. Sorry, I thought I hit record there. Anyway, sorry about that. So I'm going to use the green triangle and do long leg over short leg equals, now we'll do the blue triangle, long leg over short leg. And notice the 12 plays that dual role, being the long leg and, being the short leg in the green triangle and the long leg in the blue triangle. And so we get 144, if we cross multiply here, equals 8x. And divide by 8. And x, 144 divided by 8 is 18. So AD is 18. Number 25, using the diagram below, we're finding BD and AB. Okay? And notice on the test, I could just ask you to find AB. Okay? We'll address that in a minute, but let's find BD first. So I'll put an X on BD. And notice it's the altitude. I'll use the 2 smaller triangles. The yellow guy here and the green guy here. So we'll set up our proportions. Long leg over short, easy in the green triangle, 6 over x equals, again, long leg over short, that's x, in the yellow triangle, that's x over 3. And again, x plays that dual role. Short leg in one triangle, long leg in the other. So we'll cross multiply here, we'll get x squared equals 18. Take the square root, and x is square root of 18, which is not in simplest radical form. The biggest perfect square that divides into 18 is 9. And so x is 3 square root of 2. Now we want to find AB. There's two ways to find it. Call it y. I can use the Pythagorean theorem on the yellow triangle. So that's one way. So Pythagorean theorem on triangle ABD. So I'll do that. I have 3 squared plus 3 squared of 2 squared equals y squared. 3 squared is 9 plus 3 squared of 2 squared. That literally means 3 squared of 2 times 3 squared of 2. We do our addies times our addies and our innies times our innies when we multiply radicals. So 3 times 3 is 9. Square root of 2 times square root of 2 is square root of 4. But the square root of 4 is 2. And so 9 times 2 is 18. So this is just 18. Equals y squared. So 9 plus 18 is 27. Take the square root. And so y is the square root of 27, which breaks down into the square root of 9 times the square root of 3, which is 3 square root of 3. That is one way to get that length. I'm going to show you another way. I'm just going to clone this page. So here's another way to get it. Okay, I'm going to do this completely different way. We won't use the Pythagorean theorem, so you don't have to. The other way to get it is to use the large triangle in a proportion. So here's how we'll do that. Let me erase some of this stuff. Here's the large triangle. I'm going to highlight it. Here's the large triangle. Okay? And here is the small triangle. We're going to use this one because we want to find AB, which I'll call y. So notice y is the hypotenuse of the little triangle, and 3 is the short leg. So I can go hypotenuse over short leg to form my proportions. So I can do the hypotenuse y over 3, the short leg, equals, in the big triangle, this is the hypotenuse, which is 9. So in the big triangle, 9 is my hypotenuse, and my short leg is y. So again, y is playing that dual role. It's playing the hypotenuse in the blue and playing the short leg in the yellow triangle. And cross multiplying here, we get 27 equals y squared, which, if you look back to the other problem that we just did, is identical to this equation right here, the 27 equals y squared. So we're going to get the same exact answer, which is great. Taking the square root, we did this before, y turns out to be 3 square root of 3. So either way, if you like the Pythagorean theorem better, use that. If you like the proportions better, use that. Whatever you like. Doesn't matter. They're both valid. So 26, in the diagram below we have BD is 6. And AD is 9 more than DC. So if I call DC X, that's coming at the end, call this X, AD is 9 more than X. So 9 more than x would be x plus 9. So AD itself is x plus 9. And we want to find AC. AC will be gotten at the end here because, let's say I told you x was 5. Then AD is 5 plus 9, which is 14. DC is 5. You add them together. So I'm not so worried about getting AC. I'm just worried about setting up a right proportion, solving for x. So Notice they gave us the altitude. When they give you the altitude, it's very easy. You're going to use the two smaller triangles. Here's one, and here's the other. Okay? And notice the x is going, the 6 rather, is going to play that dual role. So in the yellow triangle, I'll do long leg over short leg. So I'm going to do long leg over short leg, which is x plus 9 over 6 equals, now I'll use the blue triangle and do long leg over short leg, equals 6 over x. And again, the 6's play that dual role. The 6 is the short leg in the yellow triangle and is the long leg in the blue triangle. So we're going to have to cross multiply here, remembering to distribute. We get x squared plus 9x equals 36. Subtract 36 on both sides. We get x squared plus 9x minus 36 equals 0. Or that. Sorry. Didn't mean to write that. Equals 0. And so now we get x plus 9. Oh, that's brutal. Sorry. Not right. Oh, I didn't mean the eraser to make that big. Sorry. See, I'll eventually get used to doing this on my computer at home. But it'll take me a while because I'm a creature of habit. So x squared plus 9x. There we go. So now we have x plus 12 times x minus 3. That's the factorization. So x is negative 12 or x is 3. We must reject the negative 12 and keep the 3. So if x is 3, okay, we were looking, and this is where we have to keep in mind here, we were looking for AC. We were looking to find AC. AC is this thing here. So if x is 3, okay, 3 plus 9 is 12, and 3 down here, so AC is just 12 plus 3, which is 15. Number 27, which set of numbers can represent the sides of a triangle? Okay, this is your two little guys have to beat up the bully. So I'll list my sides in order here. 3 plus 6 is 9. 9 is not greater than 9. This does not represent the sides of a triangle. 3, 4, 12, listing my sides in order. 3 plus 4 is 7. Is that greater than 12? Nope. 2, 4, 6, already in order. 2 plus 4 is 6. 6 is not greater than 6. So it must be the last one. Let's see why. It's 3, 8, 10.9. 3 plus 8 is 11. That is indeed greater than 10.9. That's our triangle. If two sides of an isosceles triangle measure 9 and 18, the third side could be, well, if I have an isosceles triangle, potentially I could have 9, 9, 18, or 9, 18, 18. Problem with 9, 9, 18 is if I add up the two little guys, that would not overtake the big guy. So this is not a triangle. But if I take 9 plus 18, which is 27, that is greater than 18. So this follows the triangle inequality. So 18 only is the answer. Number 29 in PQR, triangle PQR, PQ is 8. So PQR, PQ is 8, QR is 10, and RP is 12. It says which list measures the angles in order from least to greatest. So opposite the smallest side is the smallest angle. Okay. Opposite the medium side is the medium angle. And opposite the largest side is the largest angle. So from least to greatest, I should have R, then P, then Q. RPQ, choice 2. And number 30 in triangle MAG, MA is 12. MA is 12, and AG is 7, so I kind of drew this goofy. Hold on, let me change the letters. So here's my 7, so I'll do this. A, G, nope. I'll get it right eventually, kids. Let's see. Keep that as G. MA is 12, so that can't be G. Sorry. is great. Okay, there we go. This is better. So MA is 12, AG is 7, and what could this be? Well, if you remember, we found a rule for this. So X can be anything in between the subtraction of the two sides we already know and the addition of the two sides we already know. So X has to be strictly between 5 and 19. Choice 3. So, choice 3 to be clear. All right, 31. In triangle ABC, D is a point on AC, E is a point on AB, such that DE is parallel to BC. If AD is 3x plus 3, CD is x plus 1, DE is x plus 5, and BC is x plus 8, they want us to find BC and AC. But when you get two similar triangles, yet again, seems to be a recurring theme on this review sheet. Whoops. Okay. Here's my one triangle, and here's the other. Okay. And notice we have to build our sides. So x plus 1 is not the side of a triangle. But if I add it to the 3x plus 3, I'll get this combined blue side, which is 4x plus 4. And now we can set up a proportion. So I'll do 3x plus 3 over 4x plus 4. That has to be equal to x plus 5 over x plus 8. And here's where we need to be careful. When we cross multiply, we have a bunch of binomials. Think of like 3x plus 3 as they're dating. And then they're going to go out with x plus 8. Okay? So when I cross multiply with this, I have to write it like this. Okay? 3x plus 3, 3x and 3 are dating, they're coming. X plus 8, they're dating, they're coming. But they're coming together. Okay? Equals 4x plus 4 and x plus 5. And I didn't mean to write that 4 like I just learned how to write, so here's 4x plus 4. And now if you write it like this, you'll see the need to distribute. If you write it like a lot of kids do 3x times x is 3x squared, 3 times 8 is 24, and they're done. Well, we have a binomial times a binomial, so you have to use what you guys learned as FOIL or distribution. So 3x times x is 3x squared. 3x times 8 is 24x plus 3x plus 24 equals 4x squared plus 20x plus 4x plus 20. And yeah, we have some algebra ahead of us, but that's okay. Combining like terms, we have 3x squared plus 27x plus 24 equals 4x squared plus 24x plus 20. We have a quadratic. We have x squared terms. Well, where do I have more? Kind of look at it like this. Where do I have more celebrities? On the left or on the right? Well, I have more on the right, so I'm going to move everybody over to the right side. So I'm going to subtract 3x squared, 27x, and 24. So we get 0 equals x squared minus 3x minus 4. Wow, so all that algebra, all this algebra, turned into this, which isn't so bad. So now we have 0 equals, factoring here, I have x minus 4 times x plus 1. And now we get x is equal to 4, or x is negative 1. But if we look back up, of course, x, if x were negative 1, for example, the PCD would be 0. So this we have to reject. This doesn't give us meaningful answers. So x is 4, but what did they ask us for? They asked us to find the lengths of BC and AC. BC and AC. So BC was just x plus 8. Well, that's pretty easy. If BC was x plus 8, so I'll do this in a different color. Do my answers here. Make a little box for my answers. BC would have been 4 plus 8, which is 12. And then AC was 4x plus 4 we figured out. So AC is 4 times 4 plus 4, which is 20. And those are our final answers. All right, number 32, it says the length of sides of a triangle measure, say, 8, 13, and 20. What is the length of the smallest side of a similar triangle if its largest side happens to be 30? And its smallest side we'll put here. And this is an easy question. You set up a proportion. 8 over 20 equals x over 30. Cross multiply, we get 240 equals 20x. Divided by 20, x is 12. Number 33, if the sides of a triangle measure 12, 14, and 16. So here's my 12, 14, and 16 triangle. Just find the perimeter of the triangle formed by connecting the midpoints of the original triangle. So here, I'll put in the midpoints. Okay? Put them in the smiley faces. There are my midpoints. For now, I'm going to connect just 2 of them. I'm going to connect this guy. Okay? Now notice something. If these smiley faces are all midpoints, then what happens is that these pieces, for example, are equal. And so if the whole thing is 12, this is 6. So notice this little triangle up here, this side anyway is half this one. And then 14, same thing. This piece is equal to this piece. So this is 7. So notice what happens is I get a baby triangle that's half of the full triangle. Well, that applies to the third side. So if this third side, the third side, notice, doesn't really correspond the same way as the other two, but it corresponds to the 16. So dividing the 16 by 2, I get 8. Okay, well, that's not what we asked about. We asked about the perimeter of the triangle connecting all 3 midpoints. So here's another side. But notice, this side corresponds to this big side. And in the same way, this little side triangle is half of the big one. So if this is 14, this is 7. And in the same way, this is 12, this side is 6. So we have that actual triangle in the middle that the question wanted us to find the perimeter for. This guy right here. So the perimeter is 6 plus 7 plus 8, which is 21. Another way to do this, which is kind of maybe somewhat easier, the perimeter of the original triangle is equal to 12 plus 14 plus 16, which turns out to be 42. Notice this is just 42 divided by 2, so that's another way to approach it. Number 34, the areas of 2 similar triangles are in the ratio of 4 to 9. So my area ratio is 4 to 9. It says that the length of one of the sides of the smaller triangle is 9. What is the length of the corresponding side of the other triangle? Well, this requires us to take our area ratio. Whoops, I keep doing that, I'm sorry. The area ratio and doing something to the area ratio to make the sides ratio. And what we do with it is we take the square root of this ratio. This is 2/3. So now it says the length of one side of the smaller triangle is 9. I know the ratios of the sides, or the ratio reduces to 2/3. So I can go say 2/3. This is the small triangle, this is the large triangle. Equals, well, I know the small side is 9. What's the corresponding large side? So we can just cross multiply here. We get 2x is 27 divided by 2. X has to be 13.5 for our final answer. Number 35, in the figure below, AB is parallel to PR. So what that creates are 2 similar triangles. This guy right here and this guy right here. Okay? And PR is 9 and AB is 6. The area of PQR is 63, and it wants us to find the area of AQB. Interesting question. So here's what we know, okay? The sides ratio we can figure out because we have 2 corresponding sides. The sides ratio is 6 to 9, which reduces to 2/3. I have the area of the yellow triangle, and I want to find the area of the blue triangle. So what we can do from the sides ratio is kind of do what we did in the last problem, but in reverse. Namely, find the area ratio, which is the square of this thing, which is 4/9. And now I could say, so I have my 4/9. This is the area ratio, okay? Has to equal my small area, which we don't know. This is x. The small area is x. Over the large area, which we do know, which is 63. So 4/9, this is the area ratio, has to equal what the true area of the small triangle is, divided by the true area of the large triangle. 63 times 4 is 252, equals 9x, and divide by 9, and x should be 28. X is 28. Couple more questions. So 36, find the ratio of the lengths of a pair of corresponding sides in two similar triangles if each of the following gives the ratio of the areas. So we just take the square root of the top and the bottom here. We would get 2/3 for A. So I'm sorry, I'm not really showing any work, which is kind of silly. I'm just talking through it. This is the square root of 4 divided by the square root of 9, which is 2/3. That's my A. B, take the square root of 36 divided by the square root of 25, which equals 6/5. C, take the square root of 1, times over the square root of 49, which equals 1/7. D, take the square root of 4 to the square root of 25, which is 2/5. And E, take the square root of 81 to the square root of 121, which is 9/11. And these ratios at the end are the final answers for the questions. Very straightforward. 37, two squares have areas of 9 and 25 square centimeters. What is the ratio of the perimeter of the smaller square to the perimeter of the larger square? The area ratio would be, area ratio is 9/25. Taking the square root of these ratios will give us the sides ratio, or also, this is the sides ratio. It's also the perimeter ratio. Because these two things are equal. So 3/5 is our answer. Number 39, if PQR are the midpoints of the sides of the triangle, we want to find the perimeter of the big triangle. So this goes back to a problem we did. If this is 16, this thing gets doubled. They kind of correspond, or they do correspond. And this is 32. And remember, the midpoint triangle is similar to the big triangle. So again, this side corresponds to this one, so I can double it and get 34. And one more. This side corresponds to this one. Doubling it, I get 36. So I could find the perimeter by adding 36 and 34 and 32, which 6 plus 4 is 10 and 2 is 12, and we get 102. And one more question. Given ABC, I should have told you, I forgot to put this in the question, DE, or actually I got this from a book and the book forgot to put it in. DE is parallel to AC, so we definitely know we have similar triangles. BE is 8, EC is X, DE is 5, and AC is X plus 4. We want to find BC. And again, we have to build our sides. So here's one triangle. Here's the other triangle. I must build this side as X plus 8. And as I'm doing this during the hurricane, the wind's getting pretty loud out there. Hopefully we can get to this one last problem without a problem. So we get, let's see, I'll do 5 over X plus 4. Bottom over bottom equals side over side, which is 8 over X plus 8. Please remember to distribute through your binomials. And we get, let's see, 5X plus 40 equals 8X plus 32. I'll subtract 5X from both sides, and I get 40 equals 3x plus 32. Subtract 32 on both sides. I'll get 8 equals 3x, so this answer is going to be a little obnoxious. Divided by 3. You could leave this as 8/3, or you could do the division on your calculator and get 2.6 repeating. Either way works. And that's it.